Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to write a formal proof to show that two triangles are congruent. How are we learning it? Through the Congruent Triangle Proofs Part 1 notes and the Congruent Triangle Proofs Part 1 assignment. When can we use this information? To formulate well-thought, articulated arguments to defend your opinions on various topics. How do you know you learned it? By getting a score of 4 on the Congruent Triangles Proofs Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the Congruent Triangles Proofs Part 1 notes, and I'll give you time to complete the Congruent Triangle Proofs Part 1 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Geometric Proof Study Guide and any incomplete assignments that you may have. Let's take a look now at the Congruent Triangle Proofs Part 1 notes. The notes begin with the learning goals and success criteria. Now, understanding congruence. In order to show that two triangles are congruent, we must show that all the sides and all the angles are congruent. So first we need to state the parts that are congruent. Well, we have AB here with a single dash, and we have DE here with a single dash, so those are congruent. Now notice, I said AB is congruent to DE. I didn't say AB is congruent to ED, because that is not a true statement. In order to make a true statement, I need to follow along with the corresponding parts. So I went from the endpoint with the double arc to the endpoint with the 90-degree angle. So I need to do the same thing here. Endpoint with the double arc to the endpoint with the 90-degree angle. So it's AB is congruent to DE. Then we have BC here is congruent to EF, and AC is congruent to DF. So those show that all the parts are congruent. Then I have my angles. Angle ABC is congruent to angle DEF because they're both 90 degrees. They both have the box. Then I have angle ACB, so the single arc, is congruent to DFE, single arc as well. And then I'll do my double arc. So BAC is congruent to EDF, and those are congruent. So now we've shown that all the sides and all the angles are congruent, so therefore the triangles are congruent. So we can now say that triangle ABC is congruent to triangle DEF. Now let's take a look at side-side-side congruence. And what side-side-side congruence says is that if we know that all the sides are congruent, then the triangles must also be congruent. So again, we can say that AB is congruent to DE. We could say that BC is congruent to EF, and AC is congruent to DF. Therefore, we know that the triangles must be congruent because all the sides are congruent. So because of side-side-side, we know that triangle ABC is congruent to triangle DEF. Now let's take a look at side-angle-side congruence. So side-angle-side congruence says that if we know that two sides and the angle between them are congruent, then the triangles are congruent. Now notice here, I have a side, an angle, and a side. The order matters. If I had a side, this side, and I knew this angle, then this theorem would not work. The only way it works is if we have the two sides and the angle that goes between them. So here we know that AB is congruent to DE. And between them, we know that there's an angle here, angle ABC, that's congruent to angle DEF. And then we know that side BC is congruent to side EF. Therefore, we have two sides and an angle between them that are congruent. So therefore, we can say that triangle ABC is congruent to triangle DEF. Now let's take a look at angle-side-angle congruence. The angle-side-angle congruence says that if we know two angles and the side between the two angles are congruent, then the triangles are congruent. So if you notice, we have an angle, a side, and an angle. Again, order matters. So we have the side that we know comes between the two angles that we know. So then let's restate what we know. Well, we know side AB is congruent to side DE. We know angle ABC is congruent to angle DEF. And we know angle BAC is congruent to angle EDF. So therefore, we have two angles and a side between them that are congruent, so we can use the ASA theorem to state that the triangles are congruent. So we can say triangle ABC is congruent to triangle DEF. Now let's take a look at angle side congruence. So this says that if we know two angles and then the side after those two angles, then we know that the triangles are congruent. So here we have angle ABC is congruent to angle DEF. We have angle BAC is congruent to angle EDF. And we have side AC is congruent to side DF. So we have two angles and the side that comes after them are all congruent. So therefore, we would say the triangles are congruent. Triangle ABC is congruent to triangle DEF using angle side. Now, what are vertical angles? Vertical angles are a pair of opposite congruent angles formed by intersecting lines. So we have two lines here, and they cross each other, and notice that we have two angles that are formed here and two angles that are formed here. Vertical angles form an X pattern, and the angles that are opposite of each other are congruent. So this angle and this angle would be congruent, and this angle and this angle would be congruent. Now, what is a geometric proof? A geometric proof is a step-by-step explanation that uses definitions, properties, postulates, and previously learned theorems to draw a conclusion about a geometric statement. A geometric proof is typically done in a two-column proof with one column being the statements and the other being the reasons. So what do geometric proofs look like? They look like this. So we have a column here that represents our statements. This is what do we know? So these are the statements of we know this, we know that, and so on. Now the right side is the reasons, and that is the arguments for how we know that to be true. This is an example of a geometric proof. So it says AB is congruent to DE, and we have our reason as given. Given information is the information that they told us. So whether it's a marking or they state it in words, whatever it is, the given information is stuff that we didn't have to figure out on our own. It was told to us. Then we have AC is congruent to DE, given. Angle BAC is congruent to angle EDF, given. And then the triangles are congruent. Notice all of this was given information, but this part we had to come up with on our own, the SAS theorem, to prove that those triangles are congruent. So we use the theorems and postulates to fill in the rest of it. Let's take a look now at the congruent triangle proofs part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says to fill in the blank in the proof. So here we can see that angle ACB is congruent to angle YZX. So the triple arcs are congruent. Then it says AB is congruent to YX, which is given as well. So we know that. Now, what the other part we know is this angle here and this angle here. So we could say that angle BAC is congruent to angle XYZ. Well, do we see anything like that? So we don't see that one, but let's try it the other way. So angle CAB is congruent to angle ZYX, which is this one here. So that would be our answer. Then we'll go down and do this one. So we have RT, this one, is congruent to UT, given. And now what about this one? RTS is congruent to UTV. Well, how do we know that this angle and this angle are congruent? There's no markings. So what we should notice is they form an X pattern here with the true triangles. And if we remember back, if we have an X shape, that means that we have vertical angles and that opposite angles are congruent. So this is the vertical angles theorem. And then you'll continue to answer each of these questions until you get to the end of the activity. Once you get to the end of the activity, you'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.